This video provides easy-to-follow instructions for you to create and animate this 3-slider do-nothing machine using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 7 segments. In segment 1, you will establish the design intent and preview the top-down modeling process using Onshape. In segment 2, you will create the base. In segment 3, you will create the slider. In segment 4, you will create the handle. In segment 5, you will assemble and animate your device. In segment 6, you will make some changes to the device to see if it will update correctly. In segment 7, it's your turn to apply what you have learned and design a 4-slider version for yourself. Now you are ready to begin the project. Before we model the device in Onshape, we have to establish our design intent. For this 3-slider do-nothing machine, we have identified 3 specifications that we may want to change during the design process. First, the size of the base. In the drawing, the base is a hexagon, measuring 200 millimeters across opposite corners. We may want to make this a little larger or smaller in the final design. Next, the width of the sliders and the corresponding grooves are initially specified at 25 millimeters. This width may need to be adjusted wider or narrower. Last, the slider has a length of 46 millimeters. This may need to be adjusted a little longer or shorter for best operation. To easily make changes to the model, these specifications will be defined as variables at the top of the feature list in the Part Studio. The top-down modeling method helps enforce the design intent by allowing us to model the 3 individual parts in the same Part Studio and share selected specifications between related parts. For example, the size of the groove in the base is directly related to the size of the slider that fits in the groove. The sketch used to cut the groove can also be used to extrude the slider. This way, if the width of the slider is changed, the size of the groove will update to match. Also, when creating the sketch for the handle, we can directly reference features from the base. Then, if the size of the base is changed, the handle will also update to maintain this relationship to the size of the base. We can now start our model of this device using Onshape. I have started a new Onshape document and named it 3-slider do-nothing machine. Next, I'll check the workspace units. The length should be set to millimeters. The mass should be set to grams. Before starting to model the parts, we will set the variables and their initial values. Click on the icon for the variable table on the right. We will name each variable using all capital letters and use an underscore between words. The first variable is the base. It is a length and has a value of 200 millimeters. The next variable is the slider width. It is also a length, with a value of 25 millimeters. The last variable is the slider length. Again, it is a length and has a value of 46 millimeters. Now, notice that the variables have also been added to the feature list on the left. Before we start the base, let's review the drawing. First, the top orthographic view shows it has a hexagon shape. The width is 200 millimeters measuring across its opposite points. The front view shows a uniform thickness of 35 millimeters. In the Part Studio, I will start a new sketch and place it on the top sketch plane. Use N on the keyboard to view normal, and P to turn off the visible planes. In the sketch toolbar, click on the polygon tool and choose circumscribed polygon. For the center, click coincident to the origin. Stretch the polygon up, and when you see the vertical constraint, click to start. Moving the mouse will change the number of sides. Make sure it shows 6 sides and click to create. Click on the dimension tool and click on the circle to set the diameter. Use the hashtag from the keyboard to open the variables and choose base. Use Enter and the diameter should show 200 millimeters. This looks correct. Use the green check to accept. Right-click and choose Isometric View. From the Feature toolbar, click on the Extrude tool. This will be new. For the sketch region, click on Sketch 1. For the depth, enter 35 millimeters. Check the box for Symmetric to extrude equally above and below the sketch plane. This looks correct. Use the green check to accept. Next, we will use a sketch to define the size and location of the groove that will be the track for the slider. The size of the groove should match the slider, so we can use the slider profile to define both the groove and slider. The orthographic views of the slider shows all of the dimensions needed for the sketch. At the bottom, it has a width of 25 millimeters. The sides are sloped inward at an angle 76 degrees. The total height is 25 millimeters. The bottom of the slot is centered in the middle of the base. I will start a new sketch and choose the front sketch plane from the feature list. Use N on the keyboard to view normal to the sketch plane. Use a line to rough out the shape of the slider. Using the Dimension tool, click on the bottom. Use the hashtag from the keyboard to open the variables. Choose Slider Width from the list. Use Enter and the value should be 25 millimeters. Next, click on the bottom and one side, enter the angle of 76 degrees. To make both sides the same angle, use the Equal constraint from the Constraint menu. Click on the Dimension side and then the other side to set them equal. Click on the top and bottom and set the height to 25 millimeters. To locate the sketch on the base, click on the origin at the center, then the bottom of the sketch. From the Constraint menu, choose Midpoint. The middle of the sketch should snap to the origin. This looks correct. Use the green check to accept the sketch. Right-click and choose Isometric from the pop-up menu. We can now use the sketch to remove material to form one instance of the groove. Click on the Extrude tool on the feature toolbar. Click on Remove. Choose Sketch 2 from the feature list. For the end type, choose Through All. Check the box for Symmetric to remove material in both directions. This looks right. Choose the green box to accept. Looking back at the drawing, the base has a total of 3 slots equally spaced around the center. From the Feature toolbar, choose Circular Pattern. From the drop-down menu, choose Feature Pattern. For the feature to pattern, choose Extrude 2 from the feature list. For the axis of the pattern, click on the button to choose a mate connector. Click on the origin at the center of the base to choose the mate connector. For the instance count, enter 3. Check the box for Reapply features. This looks correct, so use the green check to accept. Next, we will create the slider as a new part in the same Part Studio. In the last sketch, we defined the profile of the slider. Looking at the drawing, the front view shows the length is 46 millimeters. We can use the sketch region in Sketch 2 that we used to cut the groove to create the slider. Choose Extrude from the Feature toolbar. From the feature list, choose Sketch 2. Click on New in the dialog box to make this a new separate part. Click on the depth and use the hashtag from the keyboard to open the variable list. Choose Slider Length from the list. Check the box for Symmetric to extrude in both directions from the sketch. The depth value should display 46 millimeters. This looks correct. Use the green box to accept. Looking at the parts list, below the feature list, there are now 2 parts listed. Clicking on Part 1 shows the base is selected. Right-click on Part 1 and choose Rename. Enter base for the name. Rename Part 2 as the slider. Looking at the exploded assembly view, the handle is attached to the slider using a self-tapping screw. To receive the screw, we need to place a pilot hole in the slider. The orthographic drawing shows the hole is centered on the top face of the slider. The hole has a diameter of 4.8 millimeters, drilled to a depth of 15 millimeters. We can place this hole using the Hole tool on the Feature toolbar. Click on the Hole Feature tool. This will be a metric hole, and it will be simple. For the hole type, it will be drilled. For the drill size, choose 4.8 millimeters. For the start plane, start from part. For termination, choose blind. For the depth, enter 15 millimeters. For the sketch point for the hole, click on the button to choose a mate connector. Because the hole is centered on the part surface, there will be a mate connector available to choose. Click on the mate connector at the center of the top face. This looks correct. Choose the green check to close. To check the depth of the hole, from the View menu, select Section View. Click on the end of the slider and use the arrow to view the slice that contains the hole. This looks correct. Use the red X to close the section. Next, we will create the handle that attaches to the sliders. First, the top orthographic view shows that the handle has two arms that intersect, forming a T. The ends are rounded with a radius of 10 millimeters. This makes the width of the arms 20 millimeters. The handle has 3 holes used to attach the handle to the sliders. At the end is a hole to fit the handle pin. The length of the arms and the location of the holes are determined by the placement of the sliders, which is all relative to the size of the base. The center hole in the handle is coincident to the center of the base. The arm holes are located 15 millimeters from the end of the grooves. The handle pin hole is located 10 millimeters from the outside edge of the base. We can use these reference points to create a handle that will be responsive to any changes in the size of the base. Start a new sketch. Click on the top face of the slider to select it for the sketch plane. Use N on the keyboard to view normal to the sketch plane. We need to select some features from the base part to use in this new sketch. Click on the Use tool on the sketch toolbar. Select the end point of these 2 grooves to make them available to use in the sketch. We will now use construction lines to reference these points on the base. Click on the Line tool and Construction. Click coincident to the end of the groove to start the line. Stretch the line down the groove toward the center and double-click to end. Repeat this process on the lower groove. From the Constraint menu, choose Parallel. Click on the construction line and then the edge of the groove to make them parallel. Click on the Dimension tool and click on the line. Enter 15 millimeters for the length. From the Constraint menu, choose Equal. Click on the dimension line and then the other line to make them equal. We can now use the endpoints of these lines as the center locations of the holes that will attach the handle to the slider. Draw a construction line coincident to the end of the top line to coincident to the end of the bottom line. End the Line tool. Start a new construction line from the midpoint of this vertical line and pull the line horizontal through the center. Just past the left edge of the base, double-click to end the line. Use the Dimension tool to set the distance from the end point of the line to the edge of the base at 10 millimeters. These lines represent the center lines of the handle. The lines should all be black, indicating they are fully constrained. To create the outside edges of the handle, we will use the Slot tool from the Sketch toolbar. Click on the Slot tool and then click on the vertical construction line and then on the horizontal line. Double-click on the diameter and set the width to 20 millimeters. Click the left mouse button to end the command. Looking at the handle drawing, the top view shows that the 3 clearance holes for the screws to attach to the sliders have a diameter of 6.4 millimeters. The hole for the handle pin has a diameter of 6 millimeters. Click on the Center Point Circle tool on the Sketch toolbar. Click the point coincident to the arc center at the end of the construction line and draw a circle. Enter 6.4 millimeters for the diameter of the hole. Draw additional screw holes at the other arc center and at the origin at the center of the base. Use Equal from the Constraint menu and set the 3 screw holes equal to 6.4 millimeters. Last, the hole for the handle pin. Click on Center Point Circle, click on the arc center and enter 6 millimeters for the diameter. This looks correct. Use the green check to end the sketch. The front orthographic view of the handle shows a thickness of 5 millimeters. Click on Extrude in the Feature toolbar. For the sketch region, click on the handle sketch. Click on New to create this as a new part. Set the depth to 5 millimeters. This looks correct. Use the green check to close. Looking again at the orthographic drawing of the handle, notice the corners at the intersection of the arms are rounded. These fillets have a radius of 25 millimeters. Click on the Fillet tool on the Feature toolbar. Set the radius to 25 millimeters. Click on the corner edge on both sides to round them. This looks right. Use the green check to close. In the parts list in the lower left corner, right-click on Part 3 and choose Rename. Enter handle for the name. Looking back at the drawing of the base, the front view shows the top outside edges are rounded with a 5 mm radius fillet. This feature was left for last because often placed features, like fillets and chamfers, can cause errors by cutting off edges referenced in later sketches. From the Feature toolbar, click on the Fillet tool. Set the radius to 5 mm. Click on the top outside edges of the base to round them off. This looks correct. Use the green check to close. We have now modeled all of the unique parts needed to assemble our device. We have also created a top-down relationship between the handle and base. To test this relationship, double-click the variable listing for the base in the feature list. Change the value to 250 mm. Use the final button to view the result. Notice that both the base and the handle change size. The size of the base is driving the size of the handle. Last, we can update the appearance of the parts before assembly by changing their color. We can now place the parts in the Assembly Studio and use mates to assemble. Click on the Assembly tab on the bottom of the document window. This is our empty assembly window, ready to add parts from the Part Studio. Click on the Insert button on the Assembly toolbar. It opens displaying a list of Part Studios in the current document. Here you can see Part Studio 1 containing our 3 primary parts. Click on the Part Studio 1 and it will insert one copy of all 3 parts into the assembly window. Moving the mouse now will drag the parts around in the assembly window. When you see the parts there, click the green check and close the window. First, we need to lock the base part in the assembly window so that it can't move around. Right-click on the base and choose Fix from the pop-up menu. Notice on the Parts Instance list on the right, the base now displays an icon indicating the part is fixed. The other parts are still free to move until they have been mated to the base using assembly mates. Click on the parts and drag them off the base into an empty space in the window at the same time, making sure the base is fixed and won't move. We will need 2 more sliders for the complete assembly. We can add them now. Click on the Insert button again. Click on the slider in Part Studio 1 and then click in the assembly window to place it there. Repeat to place another slider. Use the green check to end the insert. Looking on the Assembly toolbar, there are several types of assembly mates. The mates we will use for this project are the Fasten mate, the Revolute mate, and the Slider mate. To mate the slider to the base, we will use a slider mate. Click on the Slider Mate button. The edges and faces of the parts all have automatically existing mate connectors available to use. On the bottom edge of the slider, move the mouse to see the mate connectors on the edge and click on the connector that aligns with the direction the part will move. Notice that the slide has been added to the dialog box. If you choose a wrong connector, use the red X to remove it. Now move to the bottom edge of the groove that will align with the bottom of the slider. Click on the mate connector that aligns with the edge and the part should snap into place. To check the movement of the part, click on the Animate arrow in the dialog box and the part will show its degrees of freedom to move. This slides in the groove so it looks correct. Notice that there is a primary dialog box for the slider mate and a floating toolbar. We know that we will need to continue to add slider mates for the other sliders, so use the green check in the floating toolbar. This adds the mate to the mate feature list, but keeps the mate tool active so we can add more mates. Now we can use the same process to add the slider mates to the other 2 sliders. With all 3 sliders mated, use the green check here to close and the Slider Mate dialog box. Use the mouse to click and drag each slider to make sure they will slide into their groove. This looks good. To place the handle, we will use a Revolute mate so that the handle can turn about the mate. From the toolbar, choose a Revolute mate. On the slider, choose a mate connector at the center of the top hole. On the handle, if you hover on the top of the hole, lines will appear showing the inside of the hole and points for 3 mate connectors: top, midpoint, and bottom. Hold the Shift key down to hold this view open. Use the mouse to choose the bottom mate connector. The handle should snap to the slider. Use the Animate arrow to check the motion. You may notice that the slider revolves and not the handle. This is not important as long as the movement shown is a revolution. Use the green check in the floating toolbar to accept this mate. Repeat the process for each of the sliders. If the slider becomes misaligned with the groove when the mate is applied, use the Solve button on the toolbar to apply all previous mates, and it should snap back into alignment. Use the green check on the dialog box to end the revolute mate. Using the mouse, click on the handle and move it. The sliders should move freely in the slots as the handle is turned. If the handle will not turn, check the mate feature list on the left. Make sure there are no red warnings detecting conflicts. If it still doesn't turn, start at the bottom of the mate feature list and delete mates one by one, checking to see if the assembly will move. We can now place the screws that attach the handle to the sliders. Click on the Insert button on the Assembly toolbar. Choose Standard Content to access the library of standard parts and fasteners. From the standard type, choose DIN. From the category, choose bolts and screws. From the class, choose self-tapping screws. From the component, choose cross-recessed pan-headed self-tapping screws. For the size, choose ST 6.3. This is a 6.3 mm screw. For the length, choose 22 mm. To place and mate the screws, use the mouse to click on and select the 3 screw holes on the top face of the handle. Click on Insert button to place and mate the screws. Notice that the 3 screws have been added to the instance list, and that the fasten mates have been added to the mate feature list. Last, we need to place a handle pin in the handle. Again, click on the Insert button. Again, choose Standard Content. This time, choose from iOS. For the category, choose Pins. For the class, choose Parallel Pins. For the size, choose M6, which is 6 mm. For the length, choose 24 mm. Click on the Insert button and then click to place the pin in the assembly window. Click on the Fasten Mate on the Assembly toolbar. Choose the mate connector on the bottom face of the pin. Choose the mate connector on the bottom of the handle pin hole on the handle. This looks right. Choose the green check to accept. Now we can animate one of the revolute mates to drive the motion of the device. In the mate feature list on the right, locate the first revolute mate. Right-click on the mate and choose Animate from the pop-up menu. The start value is 0. The end value is 360, which means it will rotate a full circle. The steps are set to 300, which determines the speed. A smaller number of steps makes it go faster. For playback type, choose Loop, which will make it run continuously. Click the play button to run. The view of the model can be manipulated while it is operating to view from different angles. Use the Stop button to stop the animation. Congratulations on completing your 3-slider do-nothing machine. At the beginning of the project, we set some variables to allow for making changes to the design. It was the design intent to make the parts responsive to changes in these variables. We can now make some changes to see how our device updates. Go to the part studio that contains the parts for the do-nothing machine. On the right, click on the button to open the variables table. Let's start by changing the size of the base. I think the base needs to be a little smaller. Change the variable for the base from 200 mm to 175, then hit Enter on the keyboard. The size of the base and the handle should update smaller without errors. Now, I think the groove looks too wide for the smaller base. Change the slider width from 25 mm to 20 and hit Enter. This looks better. Let's view this in the assembly window. I think the sliders should be a little shorter now that the base is smaller. Change the slider length from 46 mm to 41 and hit Enter. That looks better. View the assembly. If your machine was able to make these changes and update without causing errors, it has met the design intent by using a top-down, multi-part design method. Now that you have completed your top-down model of the 3-slider do-nothing machine, your next challenge is to build a 4-slider do-nothing machine. You are on your own to complete this, but if you need a little help getting started, keep watching. You don't have to start from scratch. In fact, you can edit and revise the parts from your existing 3-slider. To start, duplicate the part studio of the existing project. Right-click on the tab of the copy and rename to 4-slider. In this copy, click on the rollback bar and move it up to just below Sketch 1. Double-click on Sketch 1 to open it for editing. Now you can change the shape to an octagon to accommodate 4 grooves. Use the green check to close. Move the rollback bar down to just past the hole in the top of the slider. Double-click on the circular pattern 1. Change the instance number to 4. This doesn't look right. Change the instances to 8. That looks correct. Use the green check to close. Here, the slider looks a little short to span the center of the groove. Double-click on the variable for slider length. Change the length to 50 millimeters. At this point, you will need to make a handle to drive all 4 sliders. It might be easiest to just delete the features from the old handle and start a sketch for a new handle. After that, create a new assembly. Good luck! I hope you enjoyed this project. If so, look for more on cadvideotutor.com.